Okay, so let's get started. We're going to be taking a look at implementing a flame map tuning feature found in our Motec M1 programming. Now I'm working with the GPRP firmware package from Motec. The GPRP package, along with some other packages from Motec, will have this flame map feature found within that firmware set. Other third-party firmware packages may or may not have this particular feature, so you may not be able to implement this on your vehicle. But let's jump in here and take a look at where we can program our flame map and how this is going to actually work in order to create flames when we're driving our vehicle and we're using it as a kind of a showpiece. You can also create a burble or pop and bang type of effect utilizing this flame map feature. So let's jump in here and take a look. What we're going to do is move from our tuning page, and then we're going to go here under motorsports, and then we're going to move all the way across here under our option to flame. And then here, this is where we actually program our flame map feature. Now we have a lot of things to cover and how this actually works. Let's go in here to flame map mode and let's turn this from not in use to enable. So what we're going to find here is we have a whole bunch of different programming variables to account for. We first have to have a limit engine speed threshold. This is going to be saying above this engine speed, we want this flame map feature to turn on and to work. Then we're going to have, in this case, a maximum cut count and a minimum cut count. This is going to be part of the randomized cut pattern with an ignition cut. And then we also find we have a fuel volume trim. Now, when we have the flame map on, we have our fuel injectors that aren't shutting off, whether we're on the throttle or off the throttle and overrun. And then we also have this additional fuel volume added to whatever the normal fuel volume is calculated. So we convert that fuel mass to an injector pulse width. This is added on to whatever that final calculated pulse width is going to be. We also have an ignition retard that's applied. We specify the timing to what it needs to go to. We see it's pretty heavily retarded. This is going to be the actual ignition timing. So negative 20 degrees is what we command with this particular flame map feature. And then the count is going to be how it cyclically rotates the ignition timing here as it's going through the flame map cycling feature. Now, how this works and the way this is going to work is that when we're in overrun conditions, if we have really retarded ignition timing and we're not shutting off our injectors, and we also have a really large fuel volume being put into the engine, as well as having an ignition cut, we'll find what we have is a lot of unburnt fuel making its way into the exhaust stream. So once we provide this cyclic ignition cut, it's going to be going back and forth with a percentage of cut. We'll actually be able to demonstrate that here in just a little bit. You're going to find that you're going to have a lot of unburnt fuel getting into the exhaust. So we have an excessive fuel volume. So we're having a ton of fuel being put into the exhaust stream that's not combusted because we have this cyclic ignition cut going on. Then we're also heavily retarding the ignition timing down to what we call for here. Essentially what we're doing is creating a condition where we have all this unburnt fuel in the exhaust and we're rapidly spiking our exhaust temperature, and that will essentially combust and ignite that unburnt fuel in the exhaust stream and create a flame effect. Now it'll also create a popping and banging effect known as burble or pop and bang style tune. It'll have that as a byproduct. So what this is essentially doing is acting as a anti-lag type of effect, kind of the same way we'd expect from a rally style anti-lag to keep a turbocharger spooled up. But in this case, we're utilizing this specifically so that we can create a flame out of our exhaust. So we're creating the conditions where that happens. Now in the rally anti-lag that you'll see a lot of rally cars, they usually have a lot of flames and popping and banging when they're on lift throttle. That's to keep that turbocharger spooled up to keep the exhaust mass flow pretty high so that turbine wheel doesn't slow down and the compressor's constantly spinning. That would be a byproduct of this as well, but the goal here is really to create that flame type of effect. Now, how do we work with this? It's actually relatively simple. We're going to find here that we have this limit engine speed threshold. We have to meet this RPM or higher for the flame map to turn on. Then we have our ignition timing that we want to consider here. How much ignition retard really going to differ based on how long the exhaust is, what type of exhaust you're dealing with, how many bends there are going to be. There's a lot of, if we're creating a flame map and you have a very long exhaust, let's say it's going all the way from, let's say the header all the way back to the tailpipe, and it's not something that's going to be a hood exit exhaust, you'll find that you have to potentially run a little bit higher ignition retard to create that flame map when you're, or flaming effect, I should say. If you have a short down pipe, let's say you're turbocharged, you have an up pipe coming out the fender or out the hood, you usually need a little less ignition retard here. So we may have to go from something like 0 degrees, might give you sufficient flame type of effect, or going down to something as aggressively as something like -60, -80 degrees of spark timing. So really late combustion. And again, that's going to be at a per case basis. You have to experiment with this a little bit. The fuel volume trim will also have to be experimented with. The more fuel volume to a certain point aids in that flaming effect. Too much fuel volume being added may start to counteract that flaming. You also can sometimes change the color of the flame based on how much ignition timing we're retarding, as well as how much fuel volume trim we're adding in here. Now, when we're talking about our counts here, the out-of-the-box programming that Motec populates when you turn this feature on usually work fairly well. The cut count usually needs to be relatively low for this ignition timing, so when we actually engage the flame map.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.